So we continue the lectures. Okay, so we are still on the lecture 1, introduction to basic statistics. Okay, so these are basic things that you need to know in your statistics career. Okay, all right. So we say, why percentiles? Okay, remember we've gone through descriptive and then inferential statistics. So if you've not watched the video, go back and watch them. We've looked at variables. Okay, so if you have not checked that, so go back and check that videos too. Now we are looking at percentiles. All right. So raw data are sometimes difficult to interpret by itself. For example, you pass a shyness test, okay, and your test score is 35/50. Okay, 35/50. Okay. So I think if you get more marks, then I think you are less shy. Okay, if you get more marks, then you are less shy. So is this good or bad result? Does this mean that you are shyer than most people? Okay, now if you do any exam and then you get a 35/50, that means it's fairly a good result, so you are less shy, so it's a good result. That is, if you are the only one looking at your result, it's a good one. But now when you try comparing your results to those you took the exams with, so assuming this exam the participants were 200, okay, 200 people took the exam, and then probably your 35 you had was the lowest mark, isn't it? So even though you had a 35/50, overall you didn't do well, because comparing your marks to the entire people who took the exams, you are nowhere near, you are nowhere better. A lot of people are less shy than you are. Okay, they did well in the test than you are in the back. So that is the question the percentile is trying to answer. That if you had this, comparing with those who took the exams, what position can we place you? How many of these people are you better off than them? What percentage? Okay, what percentage of people are you better off than them? So your 35, we can probably calculate percentile and find out that indeed your marks that you got, okay, you are better off than about 60% of the people who took the test. That is percentile. Okay, percentile. You are better off than 90% of those who took the test. That is percentile. So percentile will answer such questions. Okay, all right. So whenever you do a test and then you want to see the percentage that a particular person, percentage of people that a particular person's mark was better off than, you probably consider calculating the percentiles. Okay, calculating the percentiles. So percentile shows the proportion of score that your score you had is greater than them. Okay, greater than those particular value scores. So if you see, if your shyness score is higher than 65% of the population, so 65% of the population, your score is higher than them, then we can say that your score is the 65th percentile. That means when we divide, or we say the whole population is 100%, 65 of them you are better off than them. Okay, so percentile will tell you that indeed you had 35/50, but 65% of the population are below your mark. Okay, so you did well comparing yourself to all of them who took part in the test. All right, so there are different definitions. Okay, different definitions of calculating percentile, so we'll look at them. So definition 1, the ith percentile is the lowest score that is greater than I% of all scores. Okay, So if you say your 60th percentile, then you are looking at the lowest score that is greater than 60% of all scores. Okay, so like the example, you took the test and then you had your mark, but you want to find out let's say the 70th percentile, and to check whether indeed your score is within that level, and your score is in there, right? So to do that, you're looking at the 60th percentile or the 70th percentile. That would be the lowest score that would be greater than 70% of all scores. So that value you will get 70th percentile will be that your mark, or that value at the 70th percentile, is greater than 70% of the scores in the population, or in those who took the exam. All right, greater, strictly greater. So definition 2 is saying that it's greater or equal to. So here it's not strictly greater, less, greater or equal to. Okay, and then the definition 3 is trying to use the ordinal rank. Okay, so the ith percentile of a list of n ordered values sorted from least to greatest. So to calculate percentile, you must arrange the marks. So if 200 people took the exams, before you'll be looking at the 70th percentile, the 6th percentile, the 80th percentile, the 25th percentile. You have to arrange them in order, okay, from the highest, from the lowest to the highest, so from the least to the greatest. Okay, so in the score computed according to the following. So then to compute the various percentile, you compute the ordinal rank by the formula. So the ordinal rank here is this: R is equal to I will be the percentile value. So maybe you want the 70th percentile, so I will be 70, okay, over 100 times n. N will be the total scores, total people. Okay, so if like 200 people took the test, then that will be 200. Okay, so 200 plus 1. So you want the 70th percent, so 70 over 100 times 200 plus 1, then you find R. Okay, now if R is an integer, then if you get R to be an integer, then I is a score with the index R. Okay, I is a score with the index R. So if it happens that you calculate this value, the rank, you calculate this rank, and then it gives you an integer, let's say 60, or let's say it gives an integer, let's say 17. Okay, 17. Then you look at I17. Okay, if it is integer, then I is a score with the index 17. So if in this case 17, you go and look for 17. Okay, so the one, you have arranged the thing from 0, from the lowest to the highest. So each of them has numbers. So you go and count from the lowest up to the highest. The one on the 17th position is the one that you choose. Okay, so with the index 17, so the numbers has been arranged from the lowest to the highest. So you go and count 1, 2, 3. Then the one on the 17th position will be the one you are looking for. Okay, the one you are looking for, that's particular percentile. All right, so if it was a 70th percentile, that value you will get will be your 70th percentile. Okay, so if it happens that R is not an integer, it's a decimal point, then you take the whole number part, which is this value, take IR, and then FR will be the decimal part. Okay, so that will be the integer part and then the fractional part of R respectively. Okay, all right, so you will let X1 is a score with index IR. So here for this, if the score, this is integer, you just pick the score with index IR as your particular percentile. But now you pick S1, okay, which will be the score under that. So assuming you had 17 point something, maybe 17.25, okay, so you pick 17.25. I mean, you pick 17, so you look for I17. That means you go through from the lowest to the highest, the one on the 17th position. That the score there, that is S1, okay, and then S2 will be the score in the index IR plus 1. So if this was 17, this would be 18. So you go through and look for the 18th element. All right, the score, that will be S2. Then you can put it in this formula. So your particular percentile, which is just going to give you S1, which will be the thing on the 17th position, plus the decimal fractional part of the non-integer R, okay, S2 minus S1. That will give you your percentile, okay. So there's a typical example. You have scores, and then you rank them from the highest to the lowest, okay. So you've ranked them 1, 2, 3, 4, 5. So you have arranged them, and you don't repeat ranks, okay. So 1, 2, 3, 4 up to 20. And then you say the first definition rank, you want the 25th percentile. So the first definition means just 25% times 20. There are 20 elements there, and that will give you 5, okay. So you go and look for the 5th position. What is there? What is on the 5th position? So 5th position, 1, 2, 3, 4, 5. So on the 5th position, the 5th position is, the element there is this on the 1st position, 2nd position, 3rd position, 4th position, 5th position, 6th position. All right, and this is the 7th position, okay. So ideally, if you look at the 5th position corresponding to score 5, okay, so score 5, which is on the 5th position, corresponding to score 5, that means the 25th percentile, which is strictly greater than this scores 5, okay. It should be strictly greater than 5. So remember, we said the first definition is that the percentile, the ith percentile, is that value which is greater than all the numbers up to the 25th, or that 25%. So if you look at this, 25th percentile is 6, because, right, doing the calculation, 0.25 times 20 give you 5. That is corresponding to position 5, isn't it? So position 5, the value there is 5, okay. I remember we said that percentile value for the first definition, that value must be strictly greater than that value which is on the 25th percentile. So that means we'll go in for excess, which will be greater than those values up, okay. So the second definition is greater or equal to. So in that case, we won't go greater, we'll just pick the equal to, okay. And then the second definition, when we're using the third definition, we're using the rank. So 25th percentile, so 25 by 100, there are 20, okay, of them. So 20 plus 1, that gives us 5.25. So you pick the integer parts. So, and therefore your IR is 5, and then your FR is 0.25. So you look for I5, okay. So I5 is 5. So I5 is 5. So on the 5th position, here we have a 5 here, that's I5. Then you know, so the 5th position, which is this, and then the score there is still 5, okay. And then you add 1 to this, because remember S2 is the position when you add 1 to this, the score for the position when you add 1 to this, so that means 6. So the one on the position 6 is also, the score there is still 5, so S2 is 5. So these values are your S1, these values are your S1 and S2. Okay, so S1 and S2. So the 25th percentile is S1 plus FR, S2 minus S1. That is giving us still a 5. Okay, so per this formula, the 25th percentile for the score is what? 5. So if you had a 5, you can say that you are better off than 25% of the people who took the test. Okay. So 85th percentile, this is also another example. So 85 over 100, you had 17.85, so you pick 17. Okay, so to get S1, you go to the 17th position. It's the value there is 9. You add 1 to it, so go to 18th position, the value there is 10. So you have S1 9 plus FR 0.85. Okay, then 10 S2 minus S1, that gives us 9.85. that is the 85th percentile according to this data. Okay, so remember the first, these are important things to note. Okay, important things to note. The first quartile, okay, the first quartile. So you hear that when you are drawing a box plot, when you are drawing a box plot, when we are drawing a box plot like this, you know that you will need the minimum value, and then so probably this will be the minimum. You need the minimum value, then the maximum. Okay, you need the maximum value and the minimum. Then you need I think the first quartile. So if it is the minimum, then the first quartile will be somewhere here, then the second quartile will be in the middle, the third quartile will be here, this will be the third quartile, this will be the second quartile, and this will be the first quartile, and then the maximum value. So to plot this, you will need the various quartiles. Okay, right? So we are saying that the first quartile, which is Q1, also called the lowest quartile, is equivalent to the 25th percentile. So when you divide the thing into minimum, maximum, all right, when you get your first quartile, it's the same as computing the 25th percentile. Okay, and then your second quartile, which is the median, is also the same as the 50th percentile. Take note. And then your third quartile, which is the upper quartile, is the same as your 75th percentile. Okay, so take note of that. So that is it. So from this, if you are asked to calculate K1, means calculate 25th percentile. If you are asked to calculate Q2, you know, is the 50th percentile. Q3 is 75th percentile. This calculation has been done here. You can go through and see how it was done, right? So this is example which was done per definition 1. So 25th percentile. Okay, so 25th percentile means 0.25 times how many scores are here? 1 2 3 4 5 6 7 8. So multiply 0.25 by 8, get that position. Okay, so the solution has been done here. So you have 0.25 times 8, the position is score 2. Okay, so score 2 is what? A 5. But remember, we said the first definition is strictly greater than those values, so the 7 will be your 25th percentile for this data. And then for definition 2, remember, you still go through the same thing. All right, you multiply, you get 2, but now it's greater or equal to, so score 2, this is the score 2, but it's greater or equal to, so we'll pick a 5 as our 25th percentile. So the third definition, you have to find a rank. So 25 over that, you get 2.25. You look for I, okay, I2, which is this 5. I3, you have to add 1, that is 7. Okay, you know FR is 0.25, so your 25th percentile is S1, which is a 5, okay, plus 0.25 times S2 minus S1, that gives us 5.5. okay. All right, so that is that. So this has another example. Okay, so that ends the section for percentile. Go through this example and then you'll be fine. Okay, so on the next video we'll look at measurement. Okay, all right, so have a good day.